Next, we're talking about independent and dependent events. So more events. So for independent events, we have two events where one event does not affect the other. So independent woman doesn't need a man. Just an example. For dependent, that's two events where one event affects the other. So we're going to see scenarios where this would make sense. Let's look right away at this one. Tell whether the events are independent or dependent. A box contains yellow and brown dog treats. You randomly choose one from the box and you don't replace it. Then you randomly choose another. So you're picturing this dog box. Right, there's our box. Terrible. And then we have yellow and brown dog treats. So yellow, 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 brown, brown, brown. Doesn't say how many, doesn't really matter. You randomly choose one dog treat, you don't replace it, and then you choose another. So you want to think, did the first event impact the second event? Well, at the first event, if there were 100 to start, then it would be however many over the 100. But for the second event, there's no longer 100. We took one out. We didn't replace it. So it's a different denominator. Whenever it affects the other, it's dependent. And that's exactly what this is. Dependent. Can't actually do the math because there's no numbers with this. They're just asking you, sorry for this glare, they're just asking you whether the dog treats, if you randomly choose any, randomly choose another, whether it's independent or dependent. So basically what you want to think about is if the denominator changed, it's dependent. Like if you didn't replace it, you don't replace it, it's dependent. All right, cool. So we've got a spinner here. I want you to get this spinner down. It's got 8 equal parts. And look at each part. We've got red, green, blue, red, green, blue. So not everything is the same amount, but the sections are equal. So the problem says you spin the spinner shown, which is divided into 8 equal parts. Find the probability that you get red on your first spin and blue on your second. So this is where we're actually going to do some math. We have 8 equal parts, and we're looking for red on the first spin and blue on the second. So we have to think, spinning this, the probability of the first spin, that should be a no-brainer, right? Like we could do that right now. What's the probability of getting a red on my first spin? Well, how many reds are there? And out of how many? So I have 3 8s. Then, the second spin, we want to think, if I'm spinning again, is that going to have an impact? Is my denominator changing? Nope. The 8 equal parts won't change. So for spinners, they're never going to be dependent unless, no, never. So we have, it's independent. So what's going to happen here is you just find the probability of a blue. Regardless whether it came first or second, it's the same thing. So blue on the second, well, there's 2 blues out of 8. Which reduces to 1/4. So now we need an and scenario. We want to find the probability to get red for your first spin and blue on your second. And we do multiplication with and. So what we're doing is, for independent, probability of A and B is the probability of A times the probability of B. You see that formula there? Get that down. So then we want to think the probability A and B. Well, A is 3/8, B is 1/4. So we multiply and we get 3/32. 3 times 1 is 3, 8 times 4 is 32. Now, just so you can get this down in the same area, dependent events, that glare. It's the same thing. Probability of A and B equals the probability of A times the probability of, the difference here is that this is B given A. That line is given. So B given A. Oh man, we're seeing that tomorrow. So now you're going to still be multiplying because it's an and scenario, but you're going to notice that the second fraction is going to change. Okay, let's move on. So we've got this bowl here, and the bowl contains 54 Jolly Ranchers and 36 chocolate kisses. You randomly choose a piece of candy, eat it, and you randomly choose another. Find the probability that the first piece of candy is a chocolate kiss and the second is a Jolly Rancher. So we have to first think, is it dependent or independent? Well, if I eat the candy, my denominator changes, so it's dependent. So now this is the case where I use the formula probability of A and B. And means multiply. And means multiply, so that's why this is multiplication. And it's probability of A times probability of B given A. So I've got to first think of what am I looking for probability of A? Well, that's chocolate kisses. How many chocolate kisses are there? 36. Out of how many? Well, I got to add. 36 and 54 is 90. So then times, I ate a candy. I took one out and I ate it. So my denominator is one less. It's 89. And I have to think of how many B's there are. B is the second scenario, which is eating a Jolly Rancher. Well, there are 54 Jolly Ranchers now out of 89 because I ate one. We're assuming I ate a chocolate one. You assume whatever the first one happened. That's why it says given A. That like bar A, given A, means that I picked a chocolate one. We're going to need to do more examples of these for you to really get it, but we're starting here. So then I multiply, and I get 108 over 445, and that is approximately equal to 0.243. So like 24%. That's pretty likely. That's like 1 out of 4 likely that your first piece is a chocolate kiss and your second piece is a Jolly Rancher. It's pretty good. And that's that.